Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about isometric projections. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now today's discussion will be about drawing the isometric projections of frustum of a square pyramid. Now we have a square pyramid available with us, which has been cut by a cutting plane which happens to be parallel to the base of this particular solid. So since this square pyramid has been cut by a cutting plane parallel to its base, so the remainder solid which is left after this cutting action has been completed, this will be called frustum of a square pyramid. And after the cutting, we have to discard or throw away the upper portion of this solid. Now in this problem we are required to draw the isometric projections of this frustum of the solid or the remainder solid which is left with us. Now the statement reads as that the frustum of a square pyramid has got its base equal to 50 millimeter side, that is, this is a square base, right? So this is a square base, and into the square base both the edges, they will be equal to 50 millimeter each. So all the four edges, they will be equal to 50 millimeter. Similarly, the top face has got the edge length is equal to 30 millimeter square. So again, it is a square surface over here which is having edge length is equal to 30 millimeter. That is, all the edges of the top square face will be equal to 30 millimeter, and the distance between top face and the bottom face, this is the top face, this is the bottom face or the base. So distance between these two faces will be 65 millimeter. So this we call as height of the frustum, right? So this is the frustum height. Okay, now we are required to draw the isometric projections of the square pyramid. But before we start with the construction of the isometric projections, first of all we are going to work out the orthographic projections of this frustum of a square pyramid. Now corresponding to the base, we know that the edge of the base is the square and each edge is measuring 50 millimeter. Now please check, in the top view we have drawn a square base over there, and each edge of the square happens to be 50 millimeter, and we have marked the four edges A, B, C, D over there, right? Now then once we construct this particular square in the top view, then we are going to join the diagonals AC and BD in a lighter way. Why we have to join these diagonals AC and BD in a lighter way using a construction line? Because this portion of the solid has been cut away and this has been removed. So this portion we cannot draw using the darker lines over there. So we need to work out how much portion of this solid has been cut and it has been removed. So once we join these two diagonals, that is AC and BD, then the next step is we are going to move parallel to this edge AB, and within this triangular face, that is, this is my axis point O. So within this triangular face, as I am moving parallel to the vertical plane, I'll find out that within these two lines, you see, these are my construction lines now. So as I am going to move towards the axis, at whatever point I am able to get this edge length of 30 millimeter, so I'll stop over there. It means I have found one of the edges of the top face of this frustum, because the top face of this frustum is having an edge length of 30 millimeter. So as I am moving from AB towards the axis, and I am going to measure the length between these two projections over there. These two projections mean these are the slant edges. So as I am moving towards the axis, so at whatever point I am able to get 30 millimeter edge length between these two slant edges, so it means the top portion has been obtained. Now once I obtain this edge length of 30, so the smaller square construction will be completed, which will mean that I am able to obtain this top face of the frustum, which is a square and having an edge length of 30 millimeter. So the names of these points corresponding to A. So this point will be called A1. If this is point A, this point will be A1. If this point name is B, name of this point will be B1. Similarly, this is C, so this will be C1. If this is D, name of this point will be D1. So all the 4 points of the top face of the frustum A1, B1, C1 and D1 have been obtained. And then the remaining slant edges, now this is my remaining solid. So the remaining slant edges, they are to be joined, darkened from the top view. So I am going to join A1A, B1B, C1C and D1D. Right? This completes my projections of the top view. Now, having completed the top view projections, now I want to draw the front view projections as well. So in the front view, we can see the front view of this bigger square, that is base, will be an edge view. Similarly, the front view corresponding to the top face of the frustum, it will also be the edge view, and distance between these two views will be 65 millimeter. So I have obtained the axis, and once I have got the axis, I am going to extend it, and corresponding to the base, A and D points will be projected on the XY line, that is in the form of A dash and D dash. Similarly, B and C points, they will be projected onto the vertical plane, that is again they will be drawn on the XY reference line as B dash C dash. Why? Because the solid is resting on its base on the horizontal plane. Then at the top surface of this frustum, so these are my reference line, these are my projection line. From A1 and D1, I obtain the front view points A1 dash and D1 dash. Similarly, from B1 and C1, if I draw the projector, so I will be getting top face projection points as B1 dash and C1 dash. So these are the front view dimensions and these are the top view dimensions. Now, whatever dimensions they have been obtained onto the front and the top view, now we are required to convert all these true dimensions into the isometric length dimensions over there. So for that, we need to carry out the construction of the isometric scale. We are going to draw the true scale at an angle of 45 degree. Then we are going to carry out the construction of the isometric scale at an angle of 30 degree. Then the true length distances will be marked on the true length scale, and the perpendicular projectors from the true length scale onto the isometric length scale will be drawn, and then the isometric length projections can be worked out. So all the distances from this figure, they need to be converted into the isometric length projection, and only then the isometric projections we can draw. Now, in order to draw the isometric projections, we have drawn a horizontal ground line or a datum line. A center point has been marked over here, and from this starting point or the center point, I have drawn the isometric x-axis at an angle of 30 degree. This has been drawn towards the left side. Similarly, the z-axis, that is the isometric z-axis, has been drawn towards the right side, again at an angle of 30 degree. And the vertical dimensions, they will be drawn along the y-axis over here. That is the height of the prism, that is height of this particular pyramid, which happens to be equal to 65 millimeter. So this will be drawn along the y-axis. Now, since I know that this is a square pyramid which is resting on its base onto the horizontal plane, therefore the two edges of the base, which are 50 millimeter by 50 millimeter, so they will be drawn onto the isometric axis over here, right? So here 50 millimeter edge corresponding to AB will be drawn. Here again 50 millimeter edge corresponding to the side BC will be drawn along the Z axis. Now once I draw 50 millimeter base edge over here along the X axis, and I draw 50 millimeter edge along the Z axis, then two more isometric lines I need to draw in order to obtain all the 4 points of the base over here. And we can check the length of this particular dimension is equal to 50 millimeter, right? So length of this dimension, that is BC, is equal to AB, it is equal to 50 millimeter. And once we draw AD parallel to BC, that is the z-axis, so the length of AD will be equal to the length of BC, which is equal to 50 millimeter. Similarly, the length of this edge CD, which is an isometric line, has been drawn parallel to and equal to the edge AB of this particular square, right? So the construction of the base has been completed. Now we have to draw the top face of this particular frustum of the square pyramid. In order to draw this frustum, first of all, I need to draw a square prism, right? And the height of the square prism will be equal to the height of the frustum that we have obtained. So height of the frustum is equal to 65 millimeter. So this is the height of the frustum of the square pyramid. Now initially, since I have to draw the square prism, now I have to draw 1 and 2 isometric lines parallel to the x-axis. Again I have to draw first and second isometric lines parallel to the z-axis. And in this case, since we have drawn a square prism, the edge length of the top face of this particular square prism happens to be 50 millimeter. Does it conform to the top face of the frustum? Please check. The top face of the frustum is measuring how much? It is measuring 30 millimeter. Whereas by virtue of drawing this square prism, the top face edge width is equal to 50 millimeter. So what I need to do, I need to work out the center points of or the axis points corresponding to the base, and again I need to evaluate the axis point corresponding to the top face, because once I evaluate the center line along the x-axis over here and center line along the z-axis over here, only then I will be able to reduce the size of the edges from 50 to 30 millimeter, which will be conforming to the square edge of 30 millimeter at the top. Now you see how I have obtained these axis lines. Now I have obtained the midpoint of this edge, marked it over here. I have obtained the midpoint of this edge, marked one point over here. And once you join these 2 points, so the center line along the z-axis will be obtained. Similarly, this is another edge which is parallel to BC. So work out the midpoint of this edge, mark a point. Similarly, you work out the midpoint of this edge, again mark a point, and then join these 2 points. So you will be getting a center line along the x-axis. Now having obtained 2 center lines over there, now I need to just do one simple thing. Corresponding to this axis line, 2 projection lines will be drawn, one on the either side of this axis with an offset of 15 millimeter. Similarly, corresponding to this axis line, I have to mark 2 projector lines with an offset of 15 millimeter on the other side. So please check. Corresponding to this axis line, center line, I have drawn 2 projector lines which will be at an offset of 15 millimeter from the axis. Okay, similarly on the other side, so please check, this distance is 30 millimeter. Now similarly on the other side, again this is my axis or the center line. Corresponding to this center line, again couple of projector lines they have been drawn with offsets of 15 millimeter on either side of this axis. Now by drawing these 4 projector lines which are at an offset distance of 15 millimeter from these 2 axis lines over here, now I am able to obtain a square construction at the top face of this particular square prism, right? So now this 30 by 30 square, now this conforms to the requirement of the frustum top face, that is A1, B1, C1, D1. So A1, B1, C1, D1 happen to be a square having an edge of 30 millimeter. So now with this construction we can see we have been able to obtain A1 point over here, B1 point is obtained over here, this is the C1 point, and this is the D1 point. So all the 4 points corresponding to the top face of the frustum, they have been obtained, and all the 4 points corresponding to the base of the frustum, they have also been obtained. Now we are going to join the corresponding points to see to it which of the edges of this frustum of the square pyramid they will be visible, and which edges of this frustum of the square pyramid they are not visible. So please check A1, B1, C1, D1 and A1. So this square surface which is lying at the top of this frustum, it will be visible to the observer. Why? Because the observer is going to look from this side, and these edges, they are visible to the observer because of the slant. Now we have joined these edges. Similarly, corresponding to the slant edges, please check A1 and A, it lies in the front, it is visible. B1 and B, again observer is able to see this edge. Similarly, C1 and C, this is the third slant edge of this particular square pyramid frustum which the observer will be able to see. But the fourth one, please check D and D1, it is lying on the back side, so this will not be visible to the observer. Similarly, these faces, that is A, B, B1 and A, and B1, B, C and C1, they are going to cover the 2 edges of the base of this particular square, that is CD and AD. So these edges, they will not be visible to the observer because they have been covered by these 2 faces of this particular frustum of the square pyramid. But these 2 edges AB and BC, they will be visible. So this is the complete construction of the isometric projections of frustum of the square pyramid, and we can see all the edges of the top square, that is having edge length equal to 30 millimeter, they are visible. 3 slant edges of this frustum, they will be visible to the observer, and 2 base edges, that is which are lying on the front side, they are visible. Whereas there are 3 hidden edges over there. First hidden edges AD of the base, second hidden edges CD corresponding to the base, and the third hidden edge is the slant edge which is D and D1, right? So these 3 edges, they will not be visible. Okay, so this is the construction of isometric projections of frustum of a square pyramid. So we'll be continuing with few more cases of the isometric projections of the solids in the coming lectures. So this is all for today. Thank you very much.